At 3:47 a.m. local time on June 26, a Russian S-400 radar dish scanned the skies over Crimea. In just 15 minutes, 17 Ukrainian unmanned aerial vehicles, UAVs, would reduce this radar and the entire S-400 system to a $500 million pile of scrap metal. The lead UAV, dubbed lead Beaver, had been airborne for over 2 hours, burning fuel at a rate of 3.2 gallons per hour. At its current consumption, it had 19 minutes to locate the target, 2 minutes to destroy it, and an additional 2 minutes as a buffer for errors. The timing was razor tight, with no margin for mistakes. The UAV formation spread across a 1.86-mile front at a precise altitude of 164 feet. At this height, the Earth's curvature created a radar horizon of about 15.5 miles, a basic geometric principle that Russian engineering couldn't overcome. The powerful S-400 radar could track ballistic missiles in space, but couldn't see through the ground. Physics doesn't negotiate. Ukraine deployed 17 UAVs, consisting of 7 Beaver drones and 10 AQ-400 Scythe drones. The Beaver is a kamikaze UAV, carrying a 44-pound shaped charge warhead, with an 8.2-foot wingspan, a maximum speed of 112 miles per hour, and a flight time of up to 3 hours. The AQ-400 Scythe, built simply from plywood, carries a 70.5-pound high-explosive warhead, has a 9.8-foot wingspan, a top speed of 89.5 miles per hour, and a flight time of 2.5 hours. Behind the 7 Beaver drones, the 10 AQ-400 Scythe drones maintained formation. These plywood boxes with wings were assembled in furniture factories by workers who once built kitchen cabinets. Each Scythe costs a base price of $15,000, plus $30,000 for its navigation system. This cost-to-effect ratio would make any banker jealous. 17 UAVs, totaling $425,000, were attacking a $500 million system, if they could reach the target first. The navigation system relied on 3 layers of redundancy, as Crimea has been a GPS jamming nightmare since 2022. Each UAV carried a $12 commercial GPS chip purchased from Alibaba, backed by accelerometers and gyroscopes to track every movement. The third system was pure Ukrainian ingenuity, an optical camera matching terrain to stored satellite imagery. While Russia could jam satellites, they couldn't jam these eyes. Between 3:47 a.m. and 4:15 a.m., the Ukrainian UAV formation maintained a tight pattern, flying at a low 164 feet to avoid detection. Their approach speed held steady at 157 feet per second, with the UAVs spaced 656 feet apart to minimize the risk of simultaneous detection. Ukrainian operators, from a secret base 93 miles from the target, monitored the mission via encrypted data links. Each UAV transmitted status updates every 5 seconds, ensuring synchronized operation. Meanwhile, the S-400 system at Zomkoy remained on low alert, with its radar scanning periodically and Pantsir S-1 units on standby, unaware of the immediate threat. At 4:15 a.m., the UAV swarm executed a pre-programmed dispersal. 7 drones climbed to 262 feet, still below most radar coverage but high enough for dive attacks. 5 maintained 164 feet and 5 dropped to 98 feet. This created what UAV operators called vertical distribution, forcing defenders to split attention across multiple altitudes. On the other side, the S-400 system near Zomkoy operated under standard nighttime protocols. The 92N2E gravestone radar rotated every 12 seconds, scanning for threats that shouldn't have been there. The 91N6E Big Bird radar searched deeper, detecting high-altitude intruders. With a maximum detection range of 373 miles, a ceiling of 124 miles, and the ability to track 300 targets simultaneously, the S41N6 was blind to low-flying UAVs below 328 feet. 4 launchers stood ready with 16 missiles. Each 5P-85TE launcher carried 4 48N6 missiles with a 155-mile range, Mach 6 speed, and a 397-pound fragmentation warhead. 2 Panzer S1 units provided close-in defense, equipped with 12 57E6 missiles with a 12.4-mile range, Mach 3 speed, and 30mm cannons firing at 5,000 rounds per minute. On paper, this system was nearly impenetrable. In reality, 17 UAVs were about to prove otherwise. At 4:15 a.m., the operator stared at the 92N2E screen, displaying 17 targets at 19.9 miles. His Panzer S1 could engage 3 to 4 targets simultaneously. Its maximum engagement range was 12.4 miles, effective against aircraft at 9.3 miles, missiles at 6.2 miles, and only 3.1 miles against targets with a radar cross-section below 0.1 square meters. These UAVs had a cross-section of just 0.05 square meters. Calculations showed he needed to wait until they were within 3.1 miles for a shot at hitting them. The problem, 17 UAVs spread across a 1.86-mile front, advancing at 157 feet per second. The time from 3.1 miles to impact was 104 seconds. The Panzer couldn't fire 12 57E6 missiles without reloading, and reloading took 5 minutes. Time wasn't on their side. The Panzer S1 computer began locking targets at 4:20 a.m. when the UAVs were 6.2 miles out. However, due to their small radar cross-section and GPS jamming, the 92N2 struggled to maintain consistent locks. Russian operators activated electronic countermeasures, broadcasting wideband jamming signals, but the Ukrainian UAV's optical navigation systems remained unaffected, matching terrain to high-resolution satellite data. One Panzer S1 unit attempted to down a UAV with its 30mm cannons at 5 miles, but accuracy was poor due to the target's speed and small size. The targeting computer crunched numbers, but the odds weren't good. Each engagement required 2 seconds to acquire a target, 1 second to fire a missile, 6 to 8 seconds for the missile to reach the target, and 2 seconds to assess damage. That meant 11 to 13 seconds per UAV in ideal conditions. 17 UAVs at 12 seconds each totaled 204 seconds, but the operator had only 98 seconds. Mission impossible. 20 miles north, the 91N6E Big Bird radar kept spinning, oblivious to the approaching UAV swarm. This L-band beast could see 373 miles and track 300 targets, capable of detecting a baseball at 62 miles. But its minimum altitude coverage was 328 feet. UAVs at 164 feet were like submarines. The S-400 launchers remained on standby, each 5P-85TE2 carrying 4 missiles, totaling 16. In theory, they could engage 16 targets at once. In practice, they needed the 92N2E radar for targeting data. Without a radar lock, those $1.5 million missiles were just expensive decorations. By 4:25 a.m., the situation worsened. The UAVs adjusted course, spreading their formation to 3.1 miles. They now approached at a 90-degree angle, forcing the 92N2E radar to scan a wider arc, slowing the defense system's reaction time. UAVs at 262 feet began wave-like maneuvers, randomly altering altitude by 33 feet to complicate targeting. The Panzer turret could rotate at 45 degrees per second, but tracking multiple targets across such a wide arc meant constant pivoting, losing precious time. Another Panzer unit, 0.5 miles south, faced the same math and same outcome. Between the two units, they had 24 ready missiles plus 16 in reserve. Against aircraft or helicopters, that was enough. Against a coordinated UAV swarm, they needed perfect hits every time, and even then, they'd run out of missiles before targets. Ironically, radars that could track objects in orbit and missiles that could reach the stratosphere were rendered useless by 17 plywood drones flying lower than treetops. At 4:30 a.m., the UAVs initiated their coordinated attack phase. The 262-foot group dove at a 30-degree angle, accelerating to 213 feet per second, while the 98-foot group dropped to 66 feet, using hills and trees for cover. The 164-foot group maintained a steady approach, keeping constant pressure on the 92N2E radar. Russian electronic countermeasures intensified jamming, but the UAV's optical cameras were unaffected. Some UAVs experienced minor disruptions from jamming, but backup navigation systems quickly corrected, maintaining precise formation. At 4:45 a.m., with only a few miles left, the Panzer targeting computer finally locked onto UAVs 1 and 2. Then it stuttered, struggling to prioritize the remaining 15 targets, all emitting identical heat signatures and closing at 157 feet per second. Operators could hear the computer's cooling fan scream as it tried solving 17 simultaneous engagement equations. The first 57E6 missile launched 12 seconds later, accelerating to Mach 3 in 2 seconds, streaking toward UAV-3. Its 53-pound fragmentation warhead was designed for a 33-foot kill zone, but the UAV's tiny radar cross-section caused the proximity fuse to misfire. The computer determined the closest threats were within minimum range. Flight time to target was 6.3 seconds. The proximity fuse sought a radar signature large enough to detonate, but found none. The missile passed within 6.5 feet of a Beaver and soared into the dawn sky. Recognizing the issue, the operator overrode the computer, switching to manual targeting. His optical sight now clearly showed the UAVs, dark shapes against the brightening sky. He selected a Scythe, larger and presumably easier to hit. The second missile launched. This time, the proximity fuse worked, shredding the UAV with tungsten fragments. 1 down, 16 to go. From Belbek Airfield, 53 miles northwest, 2 Su-35S fighters scrambled in support. Each carried 8 R-77 air-to-air missiles with a 68-mile range and a 30mm cannon with 150 rounds. Their Mach 2.25 top speed allowed rapid approach, but their reaction time was too slow to intervene effectively. Pilots received an emergency scramble order 90 seconds earlier after patrol teams reported suspicious UAV activity near critical infrastructure. At full thrust, the Su-35S burned 106 gallons of fuel per minute, racing toward Yankoy at 1,181 miles per hour. Flight time was about 8 minutes. At that speed, they'd arrive just in time to photograph the wreckage. The second Pantsir unit engaged 10 seconds later, its operator firing in full auto mode. The computer launched missiles as fast as possible, one every 3 seconds. Tungsten fragments hung in the air. 2 more UAVs vanished in smoke and plastic shards, leaving 14. But the UAVs executed their final attack configuration. The high-altitude group dove at a 30-degree angle, accelerating to 213 feet per second. The low group dropped to 66 feet, using terrain to break radar locks. The middle group maintained a steady approach, forcing defenders to choose between multiple threat vectors. The UAVs employed a swarm tactic, each adjusting its path based on data from others, creating an unpredictable, dynamic attack network. Just after 4:46 a.m., both Pantsir units ran out of missiles. 24 missiles had been fired, 5 UAVs destroyed, leaving 12. Reloading took about 5 minutes. Time to impact was 68 seconds. Operators switched to anti-aircraft guns. The Pantsir 30mm cannons fired at 5,000 rounds per minute, but their narrow field of fire and limited turret speed made hitting fast-moving, small UAVs nearly impossible. The S-400 launchers were finally cleared to engage, but it was futile. Without precise targeting data from the 92N2E radar, they fired blind. 2 48N6E missiles launched, $3 million of desperation streaking skyward. Designed for aircraft at 124 miles, they were useless against UAVs at 1.24 miles. Both self-destructed after failing to lock targets. At 4:47 a.m., 12 UAVs were within 1,600 feet, approaching from 7 directions at 3 altitudes. The defense system couldn't pivot fast enough to engage all of them. Operators knew what was coming. They could see, track, even smell the fear, but couldn't stop it. They watched 12 dots converge on the system's critical components, 2 targeting each 92N2E radar, 2 for each 91N6, and 4 for the launchers. The Pantsir guns spun wildly, spraying 30mm rounds but missing by yards. Each UAV carried a warhead optimized for its target. The Beaver's shape charge aimed at radars with armor-piercing metal jets, while the Scythe's high-explosive warhead was designed for large structures. Nothing could stop what was coming. At exactly 4:47 a.m., the first Beaver struck the primary 92N2 radar. Its 44-pound shaped charge turned $50 million of Russian engineering into modern art. The warhead detonated as designed, with Ukrainian engineers having calculated the optimal standoff distance, cone angle, and explosive composition. The 0.12-inch copper liner deformed into a jet traveling at Mach 23, piercing the radar's protective shell, waveguide assembly, and signal modules, exiting the other side. 37 seconds later, the backup 92N2 radar took a direct hit from UAV-7. This Beaver approached from the opposite direction, striking the radar mid-rotation. Its shaped charge hit the antenna's power feed, the system's most vulnerable point. The blast propagated down the waveguide like a directed energy weapon, frying every component in sequence. The 26-foot, 6,614-pound radar dish was severed from its mount and crashed to the ground. At 4:48:22 a.m., two Scythe drones hit the northern Big Bird radar simultaneously. Their 70.5-pound warheads didn't need shaped charges. Raw explosive power sufficed. The first warhead cracked the radar's foundation. The second, arriving 0.7 seconds later, found the weakened metal casing and tore through the entire array. The 44-ton antenna, built to withstand 93-mile winds, collapsed instantly. Debris from the blast triggered a domino effect, damaging nearby auxiliary equipment, including cooling systems and backup generators. The radar complex was now completely blind. At 4:48:45 a.m., Scythe number 13 found its target. The 5P-85TE launcher, 44 tons of sophisticated military hardware, took a direct hit on Missile Tube 3. The warhead penetrated the 0.79-inch armor and detonated inside the magazine. The 48N6E missile's solid fuel, stable under normal conditions, became unstable under the blast's shockwave. It ignited. The solid rocket fuel burned at 5,072 degrees Fahrenheit. The missile tube, designed to channel thrust downward during launch, now directed it upward. Pressure spiked to 4,351 psi in 0.3 seconds. The tube ruptured. Burning fuel sprayed across missiles 2 and 4, igniting them. In 1.3 seconds, 2,646 pounds of fuel turned three $4.5 million missiles into the world's most expensive fireworks. At 4:49 a.m., the final three Beaver drones converged on the southern Big Bird radar. 3 impacts, 3 explosions, 1 outcome. The radar, already damaged by debris from the burning launcher, absorbed 132 pounds of high explosives in rapid succession. It didn't collapse, it disintegrated. Debris rained down within a 656-foot radius. The successive blasts created a thick cloud of dust and smoke, disrupting immediate rescue or damage assessment efforts. At 4:35 a.m., the Su-35S fighters arrived. The lead pilot's radar received no signals from the S-400 system. The radars that typically guided them were now burning wreckage. Visual observation confirmed the catastrophe. 4 separate fires, black smoke rising 1,640 feet, and secondary explosions still occurring. Debris littered the area, with radar and launcher components mixed with scorched earth and vegetation. Temperatures at the site exceeded 1,832 degrees Fahrenheit in spots, preventing the pilots from approaching closer. They circled once, confirming what their sensors already showed. The S-400 system, which had protected Western Crimea for 3 years, was completely destroyed in just over 3 minutes. 17 UAVs, built from cheap materials, powered by 50cc lawnmower engines with 5 horsepower and guided by smartphone-grade processors, demonstrated the power of innovation in modern warfare. Each UAV cost about $25,000 to produce, compared to the $500 million S-400 system. This cost-to-effect ratio was not just a technical triumph, but a strategic lesson. In the era of asymmetric warfare, simple yet smart technology can topple the most expensive machines. This attack didn't just destroy an air defense system, it shook confidence in the invincibility of advanced defense networks. Crimea, a fortress once thought impregnable, had its vulnerabilities exposed by winged plywood boxes crafted in Ukraine's small workshops.